In front of you is a plug-type dispenser specifically designed for the packaging of bulk and challenging-to-flow products, featuring a hopper positioned at the bottom. The dispenser has a pipe with a diameter of 100 millimeters, a weighing platform, and a control unit. It encompasses a control unit specifically for the weight dispenser and a frequency converter. It functions on a 220-volt electrical network. The drive mechanism on this machine comprises a wattage coil chain transmission connected to the engine shaft. Let's endeavor to package it up and locate the flour. Here we have in our possession a bag filled with flour, and we shall pour this entire bag into the flour. So let's grab it and leap onto something. Approximately half. Approximately half of it. The very last one. In this way we are able to observe with precision exactly how much we are collecting. Such a remaining portion is left over. That amount is quite sufficient. With careful consideration, activated the machine and patiently waited for a little while. At this moment, the zero calibration process is currently underway. The zero gauge indicator light illuminates. Calibration of the scale platform's 0 point is being conducted. Additionally, the frequency converter is involved. Everything has been initiated. The apparatus is currently in a standby mode and is presently displaying the weight measurement. During the operational phase, please press the initiation button. At the same time, I carefully position the bucket. I don't know what the weight is there, about half a kilogram is placed. So I put the bucket has some weight like any package. We need it to be 0. We focus on that. So if we need to set it to 0, we press and hold the memory calibration button, then press the mode. The 0 calibration is in progress. Also, do not touch or shake anything. The 0 is being calibrated. Certainly. At present, we have it configured. Prior to commencing work, it is necessary to calibrate the weight. We utilize the standard weight. In this particular instance, I possess a sealed package containing 1 kilogram of buckwheat. We carefully position it on the scale and proceed to add the weight. It ought to register as 1 kilogram here. At this moment, the balance is not calibrated, displaying a weight of 683 grams, even though we have a full kilogram here. To properly calibrate the weight, we press and hold the memory calibration button, and then proceed to press the weight button. In this instance, we adjust it to precisely 1 kilogram, and here we reset it to 0. At this point, it is exactly 1 kilogram. This is the fundamental principle of weight calibration. So kilogram memory, it goes into standby mode. It's now a kilogram, not 600 grams. In this particular instance, it shows a measurement of precisely 1 kilogram. Subsequently, if we position it within a bag, the bag possesses a certain amount of weight. We will proceed to insert the bag. In this particular scenario, we have this container. It possesses a mass of precisely 264 grams. In this particular case, we press and hold the memory calibration button and then press the mode button. 0 calibration is currently in progress. Prior to this, the device must be in standby mode. Therefore, we either powered it off and then back on, or we press the stop and unload buttons to make sure the device is in standby mode. So, this is now set to 0. Or, we set the mass to 1 kilo on the discrete 46 device. Press the mode button. B. This signifies weight. Adjust the weight to 1 kilogram. Set it to 1 kilogram. Memory function. Next, we proceed to scroll. The course dosing weight is adjusted to precisely 850 grams. This is the weight it pours fast to. Then there's a top up. This particular weight is determined through experimental methods. Subsequently, the speed is adjusted to precisely 20% until the filling process is complete. This 20% represents a portion of the total speed. And 90% constitutes the primary filling from the overall speed. We do not require these parameters any further. D and minus D represent the margin of error. Approximately plus or minus 10 grams is determined in an arbitrary manner. Well, that concludes it. The remaining parameters are not particularly significant to us. We press the mode button to exit. We are dosing 1 kilogram. Let us verify the parameters that we ought to have configured. Please press the mode button. We should have these parameters properly configured. I went back to the beginning. B signifies the mass of 1 kilogram. It is configured. Next step. The mass of the approximate dosage is 520 grams. Up to the point of 520 grams, it dispenses at a rapid pace, and subsequently it gradually adds more. This represents the velocity of addition. It is 13 units out of a total of 100 possible units. The primary filling velocity is 80 units out of a total of 100 possible units. Moving on, we require the parameters for error, D and minus D. This is D, this is minus D. A tolerance of 15 grams is set. That's it, we're done. Sleeping additive. The weight is precisely 1 kilogram. It has been filled within the acceptable margin of error. Prepare a total of 5 bags. Pour out all the contents and subsequently press the flag button. An additional top-up will be conducted at this moment. One kilogram is equal to precisely 1,000 grams. The egg weighs exactly 90 grams, this specific one. I'll adjust the dose to 2 kilograms. $290. Adjust the mass to precisely 2 kilograms at this moment. Simultaneously ensure that the 1 kilogram mass remains documented here as well. Press the stop button. Cease operation and initiate the unloading process. The device ought to be in a standby mode. Afterward, we proceed to configure the subsequent page within the library. Press and hold the memory caliber firmly, then continue to press unload. Enter the library. Access the subsequent page. Wait for an estimated duration of about 5 seconds. Departed from the library. We established the mass, engaged the operational mode, initially set to mode B. This represents both mass and weight. Establish the memory to 2 kilograms. We have established the weight prior to the pouring process to be precisely 1.6 kilograms. This specific value has been determined through experimental procedures. The weight is precisely 1.6 kilograms. Memory. Modify the speed before the filling process to 15 kilograms. For recollection. Let's modify the primary filling speed to precisely 90 kilograms. Recollection of error delta and negative delta. Let's set the memory configuration to 20 grams and then deduct 20 grams from the memory setting. Afterward, we exit and press the mode button. Since the bucket dose was not appropriate for 1 kilogram, we decided to utilize this particular type of bucket. We position it on the scale platform, tear it to 0. Press the memory button, hold the calibration button, and then press the mode button. Oh, prior to that, the device is in standby mode. Stop and unload. Awaiting instructions. Please calibrate to 0. Execute the calibration process in the specified mode. Calibrated to precisely 0.2 kilograms. We have it fully configured. Now, press the start button. Certainly, 1 kilogram, 988 grams. We have established a margin of plus or minus 20 grams. Alright, proceed to prepare 5 doses. Dispensing the entire contents. Kilogram 1,981 grams. Kilogram 986. The tolerance level is 20 grams. This indicates that without dispensing up to 2 kilograms and 20 grams, the product feed drive mechanism will be turned off. Meanwhile, the product has the potential to spill over an entire container after the drive mechanism has been turned off. Let us proceed with the final dosing and update this weight in the memory storage. This is the configuration I have established for memory. not be erased even when the power is turned off. Let's modify it to 5 kilograms at this particular moment. Configure the system to 5 kilograms. Kindly press the stop button. Exiting the dosing mode, kindly unload to ensure the indicator light does not start blinking. The waiting light is on. We enter the library into memory calibration mode, meaning unloading. Memory calibration unloading. We configure the third page, abstain from taking any action, and patiently wait for 5 seconds. It exits the library mode. Subsequently, we press the mode button and proceed to set the mass. We initiate with B, representing the weight, modify the weight to 5, then store in memory. Let us move forward to meticulously adjust the configuration of the weight of the rough fill to be precisely 4600. Store in memory. Allow the amplitude of the supplementary filling to be precisely 20. Memory. Let's configure the amplitude of the primary filling to its utmost possible level. Allow it to release the memory. Let's set the allowable error margin. How should we configure it? 30. I have configured it to 50. Precisely 50 grams constitutes 1% of the memory. And we proceed further. We meticulously pack 5 kilograms, then change the bag, the container, and carefully place this particular type of tray. We tear it to 0, holding... Sure, we need to switch to standby mode. Stop operations, unload contents, tear it to 0, adjust memory, and calibrate mode. 0 has been meticulously calibrated. The indicator light illuminates, indicating standby mode. In this particular manner. Please initiate the start sequence. 5 kilograms. Configuring the weight to precisely 5 kilograms. It is configured here. Let us verify the readings. Activating the operational mode. Selecting option B. 5 kilograms have been successfully configured. Configuration completed. Scrolling through the options. Arrow indicating upwards. B. Course dosing weight. 4th 100. It dispenses quickly up to this mass. The rest goes. Gradually increase the supplement mass. Then the supplement speed should be set to 20. The primary filling speed is established at 100. The maximum speed has been configured. Additional parameters are not required. We possess D50, D50. This represents an error margin which is plus or minus 50 grams. We have already configured the primary parameters. Please press the mode button to exit. Here it is. The margin of error is approximately plus or minus 50 grams. This is within the acceptable limits of error. That is all. We create 5 loops. This is comfortably within the acceptable boundaries of error. We carefully and meticulously pour it in with precision. The current issues are clearly visible on the surface. This is the final and ultimate package. Certainly that brings it to a satisfactory conclusion. We will proceed to finalize the task utilizing the flour. Would you prefer an alternative one? That comprehensively encompasses everything.